Say in this problem, it's given that on a frictionless horizontal surface assumed to be in the xy plane, a small trolley A, this is a small trolley A, is moving along a straight line parallel to the y-axis with a constant velocity √3 minus 1 meter per second at a particular instant. When line OA makes angle 45 degree with the x-axis, ball is thrown from the origin along the surface. The velocity makes angle phi with the x-axis. Phi. Find this phi. If its velocity makes angle phi with the x-axis and hits the trolley, that means phi is obviously greater than theta. That means this phi, this is velocity vector, this is v, and suppose this velocity is u, v and u, that is vector v and vector u, and velocity of ball. Now v is velocity of the ball, and u is velocity of the trolley, which is along the y-axis. Now this v minus u is velocity of the ball with respect to trolley, vb with respect to t. Actually v, you can write this vb, velocity of the ball, and vt as velocity of the trolley. Okay, so now in the question number 1 it is given that the motion of the ball is observed from the frame of the trolley. So let's see what happens from the frame of the trolley. If you draw this x-axis, y-axis, and this was the initial angle 45 degree, and this is the trolley A, bring the trolley to rest. So if you bring the trolley to rest, that means this ball from point O will travel along this path with respect to. So along this path lies, actually this is, put this in red color, this will be this vector, velocity of the ball with respect to trolley, VB, B for ball and T for trolley. Now that means the first question is answered. The motion of the ball is observed. Calculate the angle theta made by the velocity vector of the ball with respect to the trolley with the x-axis. So obviously VP with respect to T makes angle 45 degree, because it is this is rest means it is the reference frame from where you observe this event. So that means the first answer will be 45 degree. Second answer, find the speed of the ball with respect to the surface, that means with respect to ground, that is find V. What is V or VB, whatever you call it, if phi is equal to, now phi is this angle, right? Now phi is equal to 4 by 3 into theta, that is 45 degree. So 3 into 15 is 45, so phi is 60 degree. So that means, you know that we can draw this velocity vector. This is what? This is V or VB or V, and we have this equation, right? This equation is there, V minus U. So U is along the y-axis, so minus U will be along the negative direction of y-axis. So this will be minus U. So that's 45 degree and that is 60 degree. That means how much it is? 60 minus 45 degree, right? So 60 minus 45 degree, that is, it is 15 degree. So if you look at the vector triangle here, this U, the length of this side, mod U, is equal to √3 minus 1. And now you go for the this law, so this angle is 135 degree, right? This angle is 135 degree. So you know the sine rule in the triangle. So sine rule will tell you V divided by sine 135 is equal to u, that is root 3 minus 1, divided by sine 15. So therefore V is equal to root 3 minus 1 divided by sine 15 multiplied by sine 135. Sine 135 means sine 45 actually. So therefore you can write root 3 minus 1 times multiplied by this 1 by root 2. Now 15 means it is sine 60 minus 45. So you can write root 3 minus 1 by root 2, keep it aside. So sine 60 minus 45 is sine A cos B, means root 3 by 2 into cos 45 minus cos A half sine B 1 by root 2. So therefore it is root 3 minus 1 divided by root 2, and here you have 2 root 2 and you have root 3 minus 1. So this root 3 minus 1 will cancel out and this root 2 will cancel out, leaving out 2. So that means you can write V, or velocity of ball, is equal to 2 meter per second. The speed of the ball with respect to ground is equal to 2 meter per second.